Today, let us look at a few applications of trigonometry. A girl goes to the zoo and wonders how tall the giraffe is. On her way back home, she looks at the numerous street lights and wonders how tall the lighting poles are. She goes sightseeing and looks at this beautiful tower. She can't help but wonder how tall the tower is. This time, instead of giving up, she decides to apply her knowledge of trigonometry. She knows the distance between her and the tower. Let us call it B. She looks up at the tower and with the help of a theodolite, which is an instrument to measure angles, finds out that the angle between her line of sight and the horizontal is theta. She imagines this right triangle ABC, where she knows that BC is equal to small b and angle C is equal to theta. Now she knows that tan theta is equal to perpendicular by base. And with that, she can easily find out the measure of side AB. However, AB is not the height of this tower. The residual height of the tower would be equal to her height. So the height of the tower would be equal to small p plus L, or side AB plus the girl's height. We can write AB in terms of b tan theta. Now this angle theta, where the girl is looking upwards from the horizontal, is known as the angle of elevation. Please note that this angle is while your eyes are moving upwards or looking upwards. Now imagine a bird sitting at the top of this tower. Now this bird is looking at this girl, but her eyes are moving in the downwards direction. So the angle theta that the bird is experiencing is called the angle of depression because she is looking downwards from the horizontal. It is very interesting to note the triangle ADC, which the bird would imagine, is congruent to the triangle ABC that the girl is imagining. In short, the two triangles form a rectangle. Let us look at a few problems. A tree breaks due to a storm and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degrees with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. Find the height of the broken stem. This is quite a long question, so let us break it into pieces. A tree breaks due to a storm, so we have a tree. But we are given that it breaks. The broken part bends so that the top of the tree touches the ground. And it is making an angle of 30 degrees with the ground. So let us draw a triangle ABC, right angled at B, such that angle C is equal to 30 degrees. Distance between the foot of the tree and the top of the tree, which is side BC. Foot of the tree is vertex B and top of the tree is vertex C. So we're given BC equals 8 meters. Now we have to find the height of the broken stem, which means we have to find the measure of side AB. Now we do not know AB, but we do know BC and theta. Do we know any trigonometric ratio connecting these three? Yes, it is tan theta equals AB by BC. Let us substitute the values and we get AB equals 8 by root 3 meters. Let us look at another problem. A 1.5 meter tall girl is standing at some distance from a 30 meter tall building. The angle of elevation from her eyes to the top of the building increases from 30 degrees to 60 degrees as she walks towards the building. Find the distance she walked towards the building. Once again, let us break this question into smaller sentences. We are given a girl who is 1.5 meters tall. Next, we are given a tall building which is 30 meters tall. Now the angle of elevation from her eyes to the top of the building is 30 degrees. So let us draw a right triangle such that theta equals 30 degrees, which is the angle with the horizontal. Now the girl is walking towards the building. So let us move the girl closer to the building and draw another right triangle such that theta is 60 degrees. Find the distance she walked towards the building. So we have to find the distance between the two positions that the girl is in. Alright, let us label our triangles as triangle ABC and ABD. Now the distance walked would be equal to BC minus BD. Now we are given two triangles and both of them have the side AB in common. Now let us look at triangle ABC first. We know that tan theta or tan 30 equals AB by BC. Why are we taking tan 30? Because we are given the angle 30 degrees. We know that the side AB is common between the two triangles, which might come handy. And we have to find side BC. Connecting all these three, we can use tan 30 equals AB by BC. Let us substitute the values. But we do not know the value of side AB. Let us look at this rectangle, which is formed by the horizontal distance between the girl and the building and the girl's height. We can infer from the diagram that side AB would be equal to 30 minus 1.5 meters or 28.5 meters. Let us substitute this value of AB. And we get BC equals 28.5 times square root of 3 meters. Now let us look at the other right triangle ABD. Once again, we know angle D is 60 degrees. We know the measure of side AB and we have to find the measure of side BD. Now the only trigonometric ratio connecting these three is tan. So tan 60 equals AB by BD. Once again, let us substitute the values and we get BC equals 28.5 divided by square root of 3 meters. Let us substitute these two values to find the distance walked. Take an LCM and rationalize. We get the distance walked as 19 times square root of 3 meters. Let us look at another problem. From the top of a 7 meters high building, the angle of elevation of the top of a tower is 60 degrees and the angle of depression of its foot is 45 degrees. Determine the height of the tower. Let us read the question once again. So we have a 7 meter high building and we are looking at things from the top of this building. So let us highlight this point. The angle of elevation of the top of a tower. So we have a tower and we are looking at the angle of elevation. So we would draw a horizontal and look up from the top of the building. Now this angle is given as 60 degrees. Similarly, from the same point, let us draw the angle of depression as 45 degrees. Now we have to find the height of this tower. Let us label our diagram. We have two right triangles, triangle ABC and triangle DBC. Now the height of the tower would be equal to AB plus BD. Let us draw a rectangle BCED. We can see from the diagram that the measure of BD would be equal to the height of the building, which is 7 meters. Alright, let us go back to our right triangles. Now in triangle DBC, it is interesting to note that the triangle would be isosceles. Since angle B is 90 degrees and angle C is 45 degrees, the other angle, angle D, would also be equal to 45 degrees. Hence BD would be equal to BC, which is 7 meters. If you do not like this method, you can also apply trigonometry. So look at triangle CBD once again. We wish to find side BC as it is common to the other right triangle. So we know the angle 45 degrees, we know the measure of side BD and we wish to find the measure of side BC. So the only trigonometric ratio using all these three quantities is tan of 45. Let us write tan 45 equals BD by BC and substitute the values. We still get BC equals 7 meters. So both the methods are correct, either using the property of an isosceles triangle or using trigonometry. Alright, now we know the measure of side BD and we wish to find the measure of side AB. So let us look at triangle ABC now. Now we do not know AB, but we do know BC and triangle ACB. So let us apply the trigonometric ratio concerning these three quantities. So we get tan 60 degrees equals AB by BC. Let us substitute the values and we get AB equals 7 times root 3 meters. Let us substitute this value of side AB to find the height of the tower. Taking 7 common, we get the height of this tower as 7 times root 3 plus 1 meters.